we get that right hand part. Therefore, the sum is solved. That means x square, left hand side p square minus q square is equal to x plus a into x minus a, x square minus a square whole to the power next sum. If 1 plus x square whole to the power n equal to this one, right hand expression, that is a naught plus a1x plus a2x square plus dot 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 a to n x to the power 2n, then we have to prove this one. And now let me mention that this is identity. You have learnt in lower classes a plus b whole to the power 2, a square plus 2ab plus b square, a plus b whole cube equal to a cube plus 3a square b plus 3ab square plus b cube. These are identities. Therefore, this is also identity. Already I have mentioned. Now, how to solve this? First I write that to mention here identity. Therefore, this will be satisfied by any real value of the variable concerned. That means, if we put x equal to a real value on the left side, that will be equal to the value of the expression when x equal to that value on the right side. Putting, since we see 3 to the power n, follow why we are putting such particular values. Putting x equal to 1 and minus 1 respectively. Let me clarify why I put 1. Already I have told, if I put 1, I will get the value of this expression inside bracket 3. And if we put minus 1, then 1 minus 1, that means those will be cancelled. And minus 1 whole square, that will be 1. That is why we are choosing these values. Then first we put x equal to 1, left hand side will be 3 to the power n, and just a naught, a1, a2, dot dot dot, a to n will be there. We call it number 1. When we put x equal to minus 1, left hand side will be just 1. Minus 1 whole square means 1. These two will be cancelled. 1 to the power n, that is 1. Then it will be, first term will be a naught, x equal to minus 1, therefore it will be minus a1. Minus 1 whole square means positive. That means alternate sign changes will be there. And x to the power 2n, that is even. If we put x equal to minus 1 to the power 2n, that is positive symbol. Now we call it 2. Now we add these two, therefore 1 plus 2 I write the right hand terms on the left. You see, terms occupying even places will be cancelled. Terms occupying even places, second place, then fourth place will be cancelled. Therefore, we shall get 2 into, all will be doubled. And 3 to the power n plus 1. Therefore, A0, A2, A4 plus dot 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 plus A to n will be equal to twice this, equal to 3 to the power n plus 1. Therefore, this sum will be equal to half within brackets we get that right hand part. Therefore, the sum is solved. Now, this one. Sum of the odd terms in the expansion of this is P. Sum of the even terms in the expansion of this is Q. Now, first we write that expansion first. What is that? X to the power n plus nc1 into x square plus dot 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 plus a to the power n. We don't know whether n is even or odd. That is why, as per sum, P is equal to sum of odd terms. Therefore, sum of odd terms means this will be x to the power n plus nc2 x to the power n minus 2 into a square plus nc4 x to the power n minus 4 x to the power 4 plus dot dot dot. We cannot write here the last term as we don't know the exact value of n. Therefore, we keep up to this stage. And Q will be equal to the terms placing at even. That means nc1 x to the power n minus 1 into a to the power 1 means a plus nc3 x to the power n minus 3 a cube plus dot dot dot. Now we have to prove this one first, and p square minus q square means p plus q into p minus q. That is why we first calculate p plus q and then p minus q. Therefore, p plus q x to the power n, I am writing in arranged form, x to the power n plus this, then plus this, then plus this, like this. X to the power n, then nc1 a to the power n minus 1 x plus nc2 a to the power n minus 2 into x square, then dot dot dot. Last term will be a to the power n. That means x plus a whole to the power n. Now p minus q, that will be this expression, there will be alternate sign changes. That means x to the power n minus nc1 e to the power n minus 1 x plus nc2 e to the power n minus 2 into x square plus dot 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 plus e to the power n, that means it is x minus a whole to the power n. Here better you can write here minus 1 whole to the power n. Actually don't know that, therefore finally it will be this. Therefore p plus q into p minus q, that will be equal to x plus a whole to the power n into x minus a whole to the power n. That means x square, left hand side p square minus q square is equal to x plus a into x minus a, x square minus a square whole to the power . This is of the form p to the power n into q to the power n, that is pq whole to the power n. Therefore this one we have got this result, which is RHS proved. Next we have this one, 4pq equal to this one. First of all we write the formula or identity for 4pq. Number 2, 4pq, that is p plus q whole square minus p minus q whole square. You have learned that in earlier classes, 7th, 8th standard. Now we put the values. P plus q, already we have got that, x plus a whole to the power 2n minus p minus q, x minus a whole to the power 2n, and got this result. Therefore proved.